Okay, so I have got 15 minutes, so we're going to be looking at the softmax function more in detail, at least doing some more research on Python implementations. Python implementations of softmax, the softmax function, and Python. Like, I want to see the softmax of vector x. And that's the stable. It's everywhere says the same, right? But then that's somehow not what's working. Because if I plot these, that's what I was doing here, right? So I have these in here, and then like even if I just do that version here, even if I just do that version here, okay. Even in that case, softmax is just not. It just does not. It doesn't show, like it doesn't. That's not. It's not really softmax, right? It takes any input value. It just literally puts it into 0, unless they're gonna be very big numbers. Unless, you know, like, what's that, 1 million? Let's see, I don't know. Overflow. Yeah, obviously it's an overflow because these numbers are too big. But then we can use the numerically stable thing version of it. And we'll do the same. It's the same. The fuck. It's it just doesn't, like, I'm very confused because it just goes against my understanding of like plotting the softmax function. Let's just go to Google. I mean, plotting the softmax function, because Perplexity is giving me everything you need to know. Maybe that is going to be. Okay. Sigmoid. Okay, so that's the sigmoid. Softmax activation function explained. Oh, so softmax is not the sigmoid. I always thought softmax was the sigmoid. No, this is exp. Softmax. Okay, so this seems like an article worth reading. So okay, So I train neural networks, not promote classification. Yes, so these making neural networks outputs easy to interpret. So functions from the raw input neural networks into vector probabilities. Distribution. Okay. But okay, that's good. Multi-class revisited. Not encoding. Can you see instead in section you'll learn how to see not optimal choices for the output layer. Okay, I'll just copy that. People might have to go, but anyway, that is actually a useful link, I think. Where 0? Sigmoid. It's like, what bothers me is like when you search for for images of Softmax, you mostly get the Sigmoid function. That's so fucked up, man. The argmax, okay, that's definitely good. Softmax, probability scores. From the plot of the exponential, you can see it regardless of whether the input x is positive, negative, or 0. Okay, so we like that property. Yeah, that makes sense. I'm computing some scores for 3 classes. I'm not so sure. Softmax, how to implement the softmax function. Okay. Huh. That is different in here though, isn't it? That is something a little different, isn't it? Isn't it? Let me see that. There's definitely something here that is softmax alt. So this is the same, and then we do the sum, and then it's basically around these two, sum, and then okay, no, that's just rounding it. No, it's the same. It's the same. Let's try with EZ then. Let's try with EZ. Okay. We'll just bring these. So we'll just bring these. Yeah. It's correct then. Then it's just correct. Okay. I guess, okay. I guess there is a problem with the input in here, right? Which is, I can't really have to understand this, right? So I have to understand what it's doing. It's calculating the exponent, and then it's summing all the exponents. And then essentially it just divides this one by the sum. So yeah, so I guess what it's doing is it's kind of like amplifying big values, right? Because essentially, but why is it almost all zero then? I guess if you give it like very small numbers, very equal numbers, it still will give you stuff that is kind of above zero, right? Like if I give it like a sorry. I guess because it looks at the whole thing, it looks at the whole distribution, right? So I guess if let's say if I give it like very small values, right? No, you get equal probabilities. I mean, that's fine. I mean, that's neat. Of course, because you're dividing by the sum and stuff. Essentially, you're. But then why isn't it? Then, sorry. What's confusing me is then the derivative probably doesn't behave well. Or what? Or what? I mean, it's simple, really. It is simple, right? So it's. I don't know why it doesn't have to be. I guess it's using the exponential function because it will always be a positive number and it's differentiable, because an absolute function is not differentiable, I think. So I think that is kind of it fulfills like a nice requirement. Then obviously I know why this is failing. This is like I can't test it like that, because this is obviously going to be, it's obviously going to have this shape, because essentially all the big numbers, yeah, so that is fine. I guess that's fine. I mean, I would expect it to be more gradual though, a bit softer and not like a square, but okay. I get that, it's fine. Now at least I've solved that. It's not a sigmoid. This is probably the biggest learning today. So it's not a sigmoid function. I had you see, that's the problem, people. You can't rely on even the Google stuff and the image. You have to always challenge what you're seeing, people. That's not like this is tricky. This is tricky. And then yeah. So essentially that is fine. So what I need to do next is understand why in the train file, why is the derivative working well when I remove the softmax, right? What is it? Loss function? No, it's here. No work. It's here, the objective function. If I remove the softmax, it kind of works well. If I keep it, it doesn't. Why? Okay, why? Maybe because there's too much of a spike. Maybe softmax is not the right choice when it's just no. You know what I mean? There's a lot of this. I need to figure. Okay, so next step is kind of like the derivative. So sigma's not okay. So it's important to know. Node softmax doesn't equal sigmoid, which makes sense because you want probabilities as an outcome. Yeah. Okay. See you next time. I'm a bit over time now.